Good morning to one and all. I am Parthiban, working as assistant professor in the Department of ECE, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Now I am going to talk about the subject called electron devices, which is coming under the regulation R 2025. The subject code is EC25C01. Now I am going to talk about the topic called photodiode. What is the photodiode? Why it is needed? How it differs from the ordinary diode. These are the things that we are going to see. A photodiode is a one which is a special p-n junction diode that converts a light energy into electric current. It is a semiconductor device specially designed to detect light and convert optical signals into electrical signals. Therefore, it is also known as a photodetector, or we can also say a light detector, or we can also say a photosensor. Or else we can say it is a transducer also. Unlike a normal diode, which is mainly used for a rectification purpose, this photodiode is specially designed for operating in the reverse bias condition so that it can respond effectively to the incident light. There are some common materials that can be used for photodiodes that includes the silicon, germanium, as well as indium, gallium arsenide, phosphide. These are the materials that can be used for making a photodiode. The materials that are used can be chosen based on the wavelength of the light to be detected. That was the primary concern of material selection license. Here we are showing the symbol of photodiodes. You can see the arrow that is moving towards the diode. If it is projected out, then we can say it is an LED, but the arrow is moving towards the in direction. That's why it is called a photodiode. Then we can see about the construction as well as the operating principle of photodiode. A photodiode is constructed very similar to a p-n junction diode in many ways, but it is optimized for a light absorption. It is designed with a wide diffusion region to improve the light sensitivity. When operated in reverse bias, the depletion region becomes very much wider. In the reverse bias, only a very small reverse current flows under the normal conditions. However, when the light falls on the photodiode, the photons strike the depletion region and transfer their energy to electrons. This energy excites electrons from the valence band to the conduction, generating various electron hole pairs in nature. These newly generated charge carriers are called minority carriers. When no light falls on the photodiode, the illumination is zero. Then the reverse current is also zero. This current is called popularly as dark current, we can say. Then coming on to the next, we are going to see about the working principle of photodiode. The photodiode, as I already told you, is always operated in the reverse bias condition. In the reverse bias condition, the diffusion region is very much wider and a small reverse current flows due to the minority carriers. When the light falls on the junction, the additional electron hole pairs are generated. The applied reverse voltage provides the necessary electric field to separate the carriers. The electrons move towards the positive terminal and holes move towards the negative terminal. This is quite a natural phenomena that we can expect because of the polarity distribution. This movement of charge carriers results in an increase in the reverse current. The magnitude of this current is directly proportional to the intensity of light that is falling out. Therefore, the photodiode converts the light intensity into the electric current. So that's what the diagram depicts. the operation of a perfect photodiode. The photodiode, when no light falls on the diode, as I already told you, there is no illumination at all. So under this condition, a very small reverse current still flows due to the thermally generated magnetic areas. This current is, as I already told you, called a dark current. So this dark current exists even in the complete darkness and represents the minimum current of the photodiode. When light incident on the photodiode, the total current becomes the sum of dark current plus the photo current. So it is nothing but the addition of both current that was pronounced above. For accurate light detection, the dark current should be kept as minimum as possible or as small as possible. Then coming on to the characteristics of the photodiode. Generally, the VI characteristics of photodiode shows that the reverse current increases with increasing in light intensity. In the absence of light, the reverse current is very minimal in nature. As the illumination increases, the reverse current increases proportionally. The forward bias characteristics are very similar to the normal diode, but photodiodes are behaving quite differently in reverse bias. The photodiodes are very rarely used in the forward bias. Their main operation lies in the reverse bias region only, where they can act as a light sensors. So the holes moves from the cathode and the electron moves toward the anode, hence the photocurrent is produced. As the light intensity increases, the current also increases. This is what the essence that we have found out from the working principle of photodiode. So the diagram shows the VI characteristics of a photodiode. So the first one diagram shows the characteristic curve of photodiode. So under the reverse bias voltage condition, you see by increasing the reverse bias, then the reverse current also gets increased. Initially, the reverse bias voltage is gradually increased. So under the what we can say the broke down condition or the knee condition, it raises. After that, it stabilizes permanently. So it maintains even for all the increase in the reverse bias voltage, it maintains the constant reverse current in nature. So the stability is very well maintained that you can see from the graphic representation. So this is what the characteristics of a VI photodiode. Here you can see the variation for when the dark situation is maintained, when a light level is maintained very low, when the light level is maintained quite high. You can see the difference in the production of the current as well as in the photovoltaic variation. So when dark current is maintained, the output voltage is very low. When low light level is maintained, somewhat the increase in voltage as well as increase in current can be observed. When the light intensity is quite high, you can see the difference. The output voltage is also high, the output current is also high. So this nature of curve clearly explains the nature of the photodiode operation in detail. Then we are going to see about what are the various advantages and applications of photodiode. We can see the main advantage lies in the high sensitivity, low noise, as well as small in size. Also, it is a very high speed of operation. These are the prime advantages of photodiodes. Because of these features, these photodiodes are widely used in optical communication system, fiber optic communication systems, as well as in light meters, as well as in automatic lighting system, as well as in smoke detectors, as well as in various medical equipments, and also particularly for remote control receivers. They are also used in conjunction with solar energy measurement systems also. These Photodiodes are primarily used in optical switching circuits as well as in networks also. Particularly, it is very widely used in the modern electronics devices also for converting the optical signals into electrical signals. The primary disadvantage lies with its poor temperature sensitivity as well as the dark current increases with the increase in temperature. Then the third primary disadvantage is the biasing that is required externally is also a prime concern. Then the amplification that is required as output is very small. So these are the primary disadvantages of photodiodes. So with that, I am going to wind up my lecture. So the various applications that I have already told you, it can be used for various applications. Particularly, these are the prime applications where the clock radios, camera light meters, as well as street lights, as well as industrial lighting sensors, as well as for computer tomography, as well as for analyzing samples, as well as for blood gas monitors. These are some of the major areas of application that we can go for. So the various references that I have made have been shown in the screen. So thank you for hearing my lecture. Once again, I am thanking you one and all for hearing my lecture. Thank you all.